This video will go through examples for using the midpoint and distance formulas. And the examples will answer the essential questions: how are the coordinates of the midpoint between 2 points determined? How is the distance between 2 points determined? Is a midpoint unique? The answer is yes. If you have a line segment with endpoints, there can only be one point, one unique point that represents the midpoint, which is going to cause these two segments to be congruent. There's only one point in the middle. Is a bisector unique? No. The midpoint is unique. The midpoint of a segment is unique, but a bisector, which intersects this segment at the midpoint, is not unique. We could have numerous bisectors. Here's one for instance. Here is an alternative one. And we could continue with lines, even planes are bisectors of segments. B is the midpoint of segment AC. If we know an expression for AB and we know an expression for AC, we want to solve for x. So AB is 12x plus 3. That's the distance A to B. And then the distance A to C can be represented by 25x plus 4. 25x plus 4. There's a few ways to solve for x, but AB, that distance, we know that 2 times that distance should be the same as the distance AC, 25x plus 4. Distributing the two, 24x plus 6 equals 25x plus 4. Subtracting 24x from both sides leaves an x on the right. Subtracting 4 from both sides leaves us 2 on the left. And we've solved for x. X equals 2. Again, M is a midpoint of segment AB. We have numeric values for the location of A and the location of B. Let's find M. So here's a line segment. We're saying that A is at -11, B is at 3, M is the midpoint right here. What is its location? M is the mean or the average of the two values of A and of B. Half of -8 is -4. In a coordinate plane, A is location 2, 5, B is -7, -2. Find the midpoint of AB. The midpoint M is going to have coordinates 2 plus -7. It's -7 over 2. Its y coordinates will be the mean or the average of the y coordinates, 5 plus -2 over 2. That simplifies to -5/2 and 3/2, which is -2.5 and 1.5. Now, if you're given the midpoint in one of the endpoints, we can solve for the other endpoint. We know that the point 3, -5 is actually the result, the midpoint of doing the midpoint formula with the endpoints A and C. Well, A is -9. We don't know the x-coordinate of C, so we'll say plus x. And the y-coordinate of A is 1, plus the unknown y-coordinate of C over 2, and that should get us our midpoint B, which is 3, -5. So we have two separate equations to solve. We have the x-coordinate equation, 3 equals -9 plus x over 2. And then we have the y-coordinate equation, -5 equals 1 plus y over 2. Multiply both sides by 2, cancel the 2's here, and 6 will be -9 plus x. Add 9 to both sides, and x is 15. For the y equation, if we multiply both sides by 2, we'll have -10 equals 1 plus y. Subtract 1, from both sides. Y is -11. So C is the point with coordinates 15, -11. In this example, M is the midpoint of segment AB. A line may help us visualize this. Endpoints AB. Try that again. Here's the midpoint M. We know AM has a distance 3x minus 5. We know MB has a distance 5x minus 16. Based on the definition of a midpoint, we know that those distances must be equal. And we can solve for x. Subtract 3x from both sides, add 16 to both sides, and x is equal to 11/2, or 5.5. Similar example, but now we know not just the distances of the two halves of the line segment. Let's try this again. Endpoint A, endpoint B, midpoint M. AM is 3 minus 4x, but AB, the full distance here, -7x plus 10. So again, we'll double the distance from A to M, and that will get us the full distance from A to B, -7x plus 10. Distribute our 2, 6 minus 8x equals -7x plus 10. Add 8x to both sides, we get an x on the right. Subtract 10, and we get x to be -4. J is between H and K. Now that doesn't necessarily mean that J is the midpoint, it just simply tells you the relationship in the locations of H, J, and K. So H and K. J is somewhere in the middle. In between them, we know that HJ can be represented by 3 times x plus 2. JK is 3x minus 10. The full distance from K to H is 44. Find each of the distances HJ and JK. We know by segment addition postulate that HJ plus JK needs to equal the full distance HK. So 3 times x plus 2 plus 3x minus 10 needs to equal the full distance 44. So distribute the 3, 3x plus 6 plus 3, oh, there should be an x there, 3x minus 10 equals 44. Combine like terms, 6x minus 4 equals 44. Add 4 to both sides, 6x equals 48. So x is equal to 8. Now the question asks to find h, j, and jk, so we'll plug 8 back in for x, and we get hj to equal 30. And jk, when we plug 8 back in for x, we get to equal 14. Find the distance between the following pairs of points. In the coordinate plane, our distance formula for AB, we're going to subtract the x coordinates, -3 minus 2, and square that. We're going to add that to the difference of the y coordinates, 5 minus 11, square that. -5 squared is 25, -6 squared is 36. Add those together, we get the square root of 61, which can't be reduced. That's our distance between A and B. For part B, points C and D, we're going to take the square root of the x-coordinate difference squared, 0 minus -15 squared, plus the difference in their y-coordinates squared, so 4 minus 4. 15 squared is 225. 0 squared is 0. The square root of 225 is 15.